Oh, that's an amazing intro. And yeah, so let's get started, folks. So nice to be here. And we're going to talk today about if signals are actually worth all the hype. Because I guess all of you have heard a lot of hype about signals, right? There's like a lot of frameworks are adopting, a lot of, even TC39 is talking about them, right? Right? Am I the, do I, yes? Ah, okay, cool. Awesome. Otherwise, yeah. So to get started, like, who am I? So my name is Atila, or Atila, or however rolls off your tongue. If I can understand you're talking to me, I'll reply. I work as a DevRel lead at a company called Crab Nebula. I'm also part of the Solid Developer Experience team, and I'm a Google Developer Expert for web technologies. So, and on top of that, if there's any feedback, question, whatever you want to have about my talk, besides finding me on the Slack, on JSHeroes Slack, or in the hallway, you can also just append whatever social media you want to atila.io and you find me. That's because naming things are hard, and I switch handlers on different networks and so on. But anyway, so this talk is pretty dense, has like few slides, and it's pretty dense. And the point is essentially to answer you if signals are worth the hype. And yeah, so let's get started. Yes. Thank you. Yeah, so all jokes aside, yeah, what are signals first? Before talking about signals, we actually need to talk about API architectures. There are primarily, I would say, there are two kinds of architectures. There's the pull ones, which are request-based. So you request for some data, and you get it. And then you also have push-based, which are push architectures, which are event-based. So a certain event has some data, and it sends it over to a client. These are the two most basic types. The push-based kind of works like this in the web. So you have the data source, and in our case, as front-end developers, we have the component. The component goes, yeah, got updates? No. Got updates? No. Got updates? Yeah, we do. And then you get the component, and then you get the data, put in the components, do the whole thing you got to do, and that's it. We also have push-based ones, which you have the data, and then the data just comes in, and the component needs to handle it. So this is common on, like, if you work with observables, things like RxJS is pretty common with that. It's pretty famous about that. And for the way we do, for the way we do web development in the browser, this brings, both cases actually have a few complexities, as you can see from here, if for the updates you need to have some kind of polling system and this kind of stuff every now and then. And the component is unaware when the data is coming, if the data is coming. And for the push-based systems, there are a lot of stuff that you need to handle with back pressure, or if the component is actually ready to deal with the data, and so on. Then we got also something that I like to, you'll see from different names, you can see push-pull. For the first time, I'm going to refer to it as push-then-pull, because it kind of translates very well that it's a mix of both. So we have the data source and the component. What's going to happen is the source is going to say, oh, I have an update. And then the component is going to say, sure, I'm ready to take it. And then it's going to take the data. So if, just to be very clear, the pull is what what some of you are used to with useState is a pull-based system. And what we're talking about with signals in most, the signals, when we talk about them, they're push then pull. And in a very like hand-wavy thing, that's the difference about them. To define like push and pull, there are, yeah, so there's a lot of nuance about that and so on, but for the sake of, but my best way to summarize things is a push then pull have two basic requirements. The first one is efficiency. You need to execute only what's needed. And I do get that this is subjective, especially in the web. Like recomputing data, sometimes you might not need it, but then it's important for this other thing and so on. So, and evaluating if work can be skipped or not. Some people may say this is actually not doing work. Some people may say it is doing work and so on. Yeah. And the second one is to be glitch-free, which means you don't show intermediate state. So if you have, for example, a chain of dependencies in your component tree or whatever, and component C depends on B and B depends on A. If you are in a push-based system, they're very common for having this kind of pitfall where A receives an update and then triggers an update on C, and B didn't get to update, so then you have an intermediate state. This is something that needs to be handled. And whenever you show an intermediate state where B is stale and C is updated and A is updated, that's a glitch. That's not something you want your users to see. So to have a proper push-pull system, it needs to run only what it needs to run in order to work and be glitch-free. And then, if you spend as much time on Twitter as I do, you probably see there was a lot of, and you are as, like, I'm very focused on signals, as you can see. So there was a lot of controversy from a table like this that showed up, and I'll point out what's actually came out of this. What was actually the thing that generated all this is because there was this table that defined like fine-grained reactivity on different frameworks and what were their implementation. Quick is missing there, but Quick is also fine-grained. So let's check our requirements. So they need to be glitch-free. Is Angular Signals glitch-free? Yeah. React with React Forget or compiler or plugin, I don't know. Glitch-free, yeah. They don't show intermediate states. Nuxt with shallow refs, yes. Solid start with signals, or solid with Nuxt or Vue, solid start or solid, and SvelteKit runes. All of them are glitch-free. Great. First step is done. The second one executes only the code that needs to be executed in order for our data to update. Angular Signals does that. React don't. And then you have Nuxt, Solid, and Svelte that they do that with signals. So I would say that this is a little bit, yeah, no. And I have some, we're gonna check it in code how that actually works. So whenever you have component like this, I'm sure you've seen that before a few times. What happens is I have this counter, and I'm going to trigger a new state for that counter, and I'm going to show that. Whenever an action like this triggers, by default, before any optimization, would be that like I render this component, and then if I click on it, what runs again is the entire function body, and it re-renders the whole component, even if the button itself has not changed, only the text below it. When you have signals, they're pretty much, they look the same, but then once you render them and then you click on them, the thing that updates, it's just that function call, and that's why it's a function, to be honest. It's because it's actually a getter, so the value doesn't exist inside your component. It's not stored by reference. So it means that every time we can call that function, and it's going to bring the up-to-date value. That's the whole thing about pulling the new data. So let's have a look at the proper case, because on slides I can do whatever I want, right? So where is my... Yeah, so... Oops, spoiler. So yeah, So here we are at Code Sandbox. I will. I just need to check. Yeah, so this is actually the one that we need to look first. So what we have here is, I'm trying to zoom out, yeah. There we go, this we don't need. And what I want to, it's basically a regular regular component. What we do is we have this app, and this app has a few different components. Each component is doing an enormous amount of work, and then we're going to pass the count for each one of these components and so on. And then what we do with each one of the work, it takes a parameter, and it says, yeah, I'm rendering that thing, and then it does a bunch of work. What's supposed to happen is, yeah, first time we load things, we get the app that's rendered, we get A, B, C, D, as you would expect. You need to render the whole thing. The point is, with the compiler, and we are using the compiler, I just closed the thing that proved that we were using the compiler, so yeah, we are using the compiler here, or plugin, or I don't know, people call it different things now, and I'm very confused. But awesome. So now what's going to happen is I'm going to increment, and it should do only the work that needs. So if I increment the number, only the count's going to change, right? Because nothing else is changing. That's a little bit more work than I was expecting. And so what happens in the end is here, this is using signals, and what you expect when you render is you render the whole thing, and when you increment, let me clean the console. When you increment, you only render what actually changed. And that's what the fine-grained reactivity actually means. So that's why, to me, it's not fine-grained. But back to it, back to signals and so on. Cool. So the point I'm trying to make is automatic granular memoization, which I invented that. So yeah, it's different than fine-grained reactivity. So it is a big boost, and so it's a nice performance boost. It's good to avoid doing work. It's good to cache work. You don't need to do it again. But it's not the same thing, and I think treating them as the same thing and looping them into the same category is just confusing. And I'm happy because this means that the meme that I showed on Revel.js still holds true. That is, yeah. But to be really, really honest, it is fast enough without signals. I'm not here to make a case about performance. This is not a talk about performance. This is a talk about if signals are worth the hype, and I think the performance boost that you get from fine-grained reactivity is a bonus. It's not the cause. So I don't unless you have a very specific scenario where performance is critical for your app, chances are you can write pretty performant code in any framework nowadays. They're all pretty good. Okay, so why am I here for? Why should you care about all these things that I've been talking about, or about signals? So to me, it boils down to the first rule of developer experience, which is if you have good defaults, you have good code, and if you can have good code easily, you can have better UX for your users. And that's the thing that, to me, makes signals important, because they're easier to understand. They're easier to reason about and to create a mental model. And I promise I'm not biased, or I try not to be, and I'll prove it to you with this guy. And before we go into that, I want to let you know that there are two kinds of developers. The ones that use console log. Can I have a show of hands? and the ones that don't raise hands. So let's check our next demo, which is, this is, to me, is, yeah. So here's the component that I have. The first one is, I'm creating a state that's use account, and then sets account, and then I'm creating this double count. And then I use the effect to sync. And I'm doing that, yeah. So I did some styles here just to make it look nicer. Hey. And then on click, I want to debug this button because I don't really know how it works. So what I'm going to do is I'm going to log the count, I'm going to log the double count, and I'm also going to log the text content of this thing. So we are going to open the console because I want to see. Okay, cool. So right now I have 0, which means that my double count is 0 because my count is 0, and my current event is 0, right? All good. If I increment here, who can I? Yeah, let's see. Let's do this little quiz. Who thinks it's gonna show 0, 0, 0? Who would expect that? Because that's what you want to do, or yeah. Anyways, so who think that it should show you the incremented value post to sum, and then the derived double count, and like something like 1, 2, 1? Yeah? And who would expect it to be something in the middle? So, yeah. So it really, the thing is, a lot of frameworks do it differently. Like, let's see what React does. You get all the 0, and that's because, and you're going to say, yeah, this is, you can get around with it with, what's the name? It's flush sync. So you can do that because what's going to do is, essentially what's happening is you update the DOM, and then you have the full cycle to go in and then re-render and yada yada. So this thing, the console log, hits too fast and it doesn't have the time to do the whole cycle. It reached before. And then you have frameworks like Vue and Svelte that they have different ways of dealing with the scheduler re-render. I'm talking about Vue 3 and Svelte before runes. I'm actually not sure how Svelte does when you're using runes. In the end, what's happening here is that there's the whole life cycle of updating the state. And what I think this is my playground, no. What? Yeah, so yeah, Papanaj is great, right? Or were you clapping for signals already? My talk's not done yet. Cool, so yeah, here we are. So what I think it would make more sense when you're debugging is I can read my code line by line like ChatGPT would. So it would go, oh, set count, yeah, or increment count, and then put all the things that I need there, and then I can log it, and it would make sense, like this. So that's why I think signals makes it easier for you to debug, makes it easier for you to understand. As I'm part of the Solid team, I get a lot of people that are coming from other backgrounds into signals, and they find it misleading, but that's mostly because, and that's, it's a little bit different when your framework behaves in a way that you wouldn't expect. So anyway, that's my point about debugging and why I think it went back too far. And yeah, what's the good thing about signals? So cool, you're caught up. So now you're signal heroes, all of you. Can I have show of hands for all of you? Now you know everything about signals. So we can get the talk started, that we leveled everything up. So let's address the other elephant in the room, because I've been talking about frameworks this entire time. But TC39 has a stage 1 proposal, where they actually want to add signals to JavaScript. And this is pretty great. And I hear a lot of questions about, okay, how is it going to be now for framework authors, because you have all those frameworks using signals, but then now signals go to vanilla JavaScript, so now we kill all the frameworks. Not yet, at least. The thing is, it's a stage 1, so it's not clear how it's going to be, and to be honest, not all signals are built the same. Even between the frameworks that we have today, they are not exactly the same. So I would wait a little bit longer to see what kind of, how TC39 decides to solve the problems that signals have, the trade-offs and the edge cases and so on, and how they're going to address these things inside the language before making any longer assumptions. Talking about signals being different, there are two kinds of push and pull based systems. There are the lazy and the eager ones. So the lazy ones, you have this component tree. And then you have, oh, that's horrible, that effect. So the blue thing updated, the pink one updated, the one at the bottom. And then what happens is it's going to notify the blue one that it needs some update. And then it notifies the green one that it needs update. And finally, it notifies the yellow one updates, and then it cascades down. So then blue updates, green updates, and then triggers the pink update. That's how lazy signals work. It does a little bit more passes and a little bit more work, but it's highly consistent. So it kind of ensures one of the biggest edge cases of signals, which I mentioned before, the diamond problem, that happens with push-based systems, where you have components in the middle, and the first one updates, triggers the last one, and the one in the middle is not. Lazy signals are a way of preventing this problem from happening. But we also have eager signals. Eager signals, the yellow one, the data source, is actually going to say, oh, there's an update. And then it's going to immediately trigger the ones at the bottom, so the blue and the green one. And then once the blue and the green one updates, they trigger the pink one to update. So eager is on the danger of saying something not perfect. The eager is more towards push, while lazy is more towards pull. Why there are these differences? If I already mentioned that lazy prevents a very big edge case, why people go for eager? Because you have two types of systems. You have trees that are deeper, which means you have long chain of derived things. So when one value of A, value of C depends of values of D depends of C, that depends of B, that depends of A. And you have the wide ones, where you have smaller chains, but they're broad. So you have the same data showing up at different places of your UI, in this case. So lazy ones tend to perform better on deeper levels, while eager ones tend to perform better at wider levels. There are two other things that influence this, which is memory consumption affects this greatly, but in a nutshell, from a data structure point of view, that's the main difference. Implementation is going to vary, and it's going to influence a lot, of course, but that's essentially how it goes. So the question you need to make yourself is, how is your app's dependency graph? If it's deep or if it's wide? If you don't know and if you're not sure about it, chances are it's wide. Most UIs are wide in terms of you have the same data showing up at different places of your UI, but you don't have long chain of derive. You're not like computing a bunch of stuff throughout your component tree. And remember that graph we looked at before, where we are comparing coarse reactivity to fine-grained reactivity? So now it's the point where I want to give you a takeaway where we can actually look at the other frameworks. We compared a little bit with frameworks that don't use signals, but as I mentioned before, not all signals are built the same. So now we get a new dimension to this where we see how components behave from the lazier ones to the eager ones. So the first ones are quick and angular in this case of the fine-grained reactive ones because they do have a lazier implementation, and also they have I want to call it kind of a fallback where if you fall out of the reactivity for some reason, or if something goes haywire, it actually can trigger a reconciliation. It can actually do a kind of a re-render of sorts. Not actually a re-render, but kind of it of sorts. So this is where they are. And then you get solid runes, which is svelte runes, I'm sorry. Svelte runes, which are coming out on Svelte 5, which is Svelte's implementation of signals. They are still lazy, but they are finer, and they're, as far as I could see, as far as I could understand, they are finer, and they have no kind of reconciliation step for this. And finally, you have View Vapor that is not yet on a stable release, as far as I know. But from what we've seen so far, they're like very, very fine. They're still lazy, but very, very fine. And then you have Solid that went all in with the eager, and that's actually important to point out, and was actually a decision that Solid did on doing that, because though eager is kind of harder to there's more pitfalls to implement. You need to have more checks to deal with that diamond problem. Eager was what allowed Solid to have a pretty decent concurrent mode that is as good as the reconciliation concurrent mode in other frameworks, and also is what's going to enable Solid 2.0 to come to life. So yeah, so that's the landscape of each framework. If you realize, okay, so now I want to have signals, now you know more or less how they behave. So quick and angular, kind of a transition step where they can actually do some, they can pick you up if something happens, if something goes haywire, they're more resilient. Svelte runes is Svelte runes, View Vapor, and SolidJS 1.0, they're kind of in a very close ballpark in terms of mental model. And yeah, so that's how it is. So let's do a quick recap of what we've seen. We've seen pull system, pull-based systems. We've seen push-based systems and push then pull-based systems. Yeah, now you show up, right? Cool. Then we've talked about the good. We talk about what I believe. Wait. Okay, my slides just went haywire for me. So then we talk about the things why I think signals are worth to be used, why I think signals actually help you build more resilient and better UX in your apps. And finally, once we were good with that, we saw the two different implementation cases for signals, either eager or lazy. And there I go again. And with that, I want to leave you with one question. Are signals worth the hype? My answer is yes, but I want to know your answers, so yeah, let's talk about it later. Thank you for having me, and see you around.